Hello everyone, welcome to yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on finding number of islands in a 2D matrix, and this is a very frequently asked interview question. I am sure a lot of you must have seen it already. If not, we'll go through the problem statement, we'll understand it and solve it. If you have already been through this, then it'll be a quick revision for everyone, right? So let's jump to the problem statement. Last time we have solved validate binary search tree. You can find it in the list. Let's start with number of islands. Okay. Firstly, before we start solving, the problem might seem a little complicated, but once you understand, it's really easy to solve. Okay. Let's see. Given an m cross n 2D binary grid, which represents a map of ones land and zeros water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay, let's understand from the example. So we have this grid example 1 1 1 1 0, then we have 1 1 here, then we have 1 0 0 0 0 0 0 0 0. So if you see and consider ones as land, we can see this is one land, right? And apart from this there is no other land, so this solution is 1. Then if we look at the second example, we can see these 4 is one land. This one alone is one land because on top it has 0, bottom 0, left 0, right 0. And this 2 at the end, they are land as well. This is one land as well. Top zeros, left 0, right can be considered 0, bottom can be considered 0. Since they mention, you may assume all four edges of the grid are all surrounded by water, right? Now, what can be the easiest approach and the most efficient one? Okay, please take a minute, go through this, think for a minute that the approach you would like to take, and we'll start. Okay, so let's start. Let me take this example. Okay, let's consider this example. We have this grid. Let's make it look a bit perfect. Not perfect, but slightly better. Yeah, so let's see, we have this grid. Okay, we can simply find the land by just traversing the complete 2D matrix with the two for loops I and j, and if area of ij equal to 1, then we know that it's a land, right? But then next one is also 1, so we can easily find out it's a land, we can easily find out it's a water. How will we figure out that how many total islands are there? So first thing is, let's say we create one variable for number of islands. We'll initialize it to 0. We'll start with the traversal. We see 1, we know we have found one land. We'll increment the number of islands. Now then we'll do one thing, we'll perform a depth first search on the matrix. If you look at it, it's a graph problem, right? We'll perform depth first search where we'll one by one check for all the attached ones. That is, we'll be checking recursively, like from this one we'll check the next one on the right side. Top does not exist, left does not exist, on the right there is another one. Similarly for this one we'll check left, right, top, bottom. For this one we'll check left, right, top, bottom. This one will check left, right, top, bottom. Now what we can do is we'll switch them, and from 1 we'll make them to 0. So let's say we switched all the connected ones with 0. Now we marked number of island as 1, we switched all the connected ones to 0. Now when we move forward in our for loops iteration, we'll not find any one here, right? We'll keep scrolling, and then we see another one. Then we switch this and all the connected ones to 0, and we increment this number of island to 2. Then we keep moving forward, and then we encounter another set of ones. We'll replace this one by 0 and the connected one with 0 as well, and we'll increment number of island to 3. Right? Simple. So this is exactly the approach that we are going to take. When we figure out we have found a 1, we'll increment our number of islands, and we'll do a DFS. We'll search all the adjacent ones and we'll switch them with 0. right? So that when we come to them again, we'll already know that they were visited, so now they are not ones. And when we'll encounter another one, we'll know that this is part of other island. Okay, so let's start coding. Let's start. Okay. Okay. So first let's put the base condition. If grid is equal to null, or grid dot length is equal to 0, or just like checking the column length and the row length, grid of 0 dot length is equal to 0, will simply return, because no island is possible in this case. Oops, we forgot to comment it. We'll say base condition. I think that's enough. Then let's initialize our rows, columns, and our island variable for island. You can say int num rows is equal to grid dot length. Similarly, int num columns is equal to grid of 0 dot length, and int is the function name is land count is equal to 0. Okay, now we'll start with traverse the matrix. Okay, so we'll do for int I equal to 0, I is less than num rows I plus plus, right? Simply for int j is equal to 0, j is less than num columns j plus plus. Okay, simple for loop for any 2D matrix. Now we'll check for the grid. So we'll say check for land. So if grid of I j is equal to 1. Now the 1 is taken in quotes because they are as part of the character strings, right? If we have found 1, that means we have found a land. So we can say found the start of the land, start of the land. So increment land counter, let's call it land counter, and perform DFS on the where do we want to perform the DFS? We'll perform the DFS to mark the entire island, right? It should be start of island, right? Now before we go further, let's write this code and then perform the code for DFS. So we can simply say is land count plus plus, right? So we incremented the land counter, and now we want to perform a DFS which will mark all the adjacent ones with zeros, so that we'll know that all those different endpoints have been visited already. So we'll create a method DFS, we'll pass the grid, we'll pass I, we'll pass j. That's it. Okay, in the end, when the for loops is over, we will return is land count. Okay, so let's quickly write the DFS. Private void DFS. We don't want to return anything, we just want to perform changes to the same matrix and replace ones with zeros, right? So we'll receive character grid, it's grid of characters. Okay, int row, int column. Now int num rows, as we did earlier, is equal to grid dot length, int num columns is equal to grid dot grid of 0 dot length. That's it. Now we need a base condition for recursion, right? So we'll say call it base cases for recursion. So if row is less than 0, right? If the row is less than 0, or column is less than 0, or row is greater than equal to num rows, or column is greater than equal to, what should column be greater than equal to? Num columns. So let's leave some space here, right? What else is left? Also, if it is already water, right? So grid of row column is already equal to 0. That means it's already water. In any of this case, that would mean if the row is behind outside this matrix, or the column is outside this matrix, either in negative direction or in positive direction, or the value is already 0, that means it's water, will simply return from this recursive call. Otherwise, we'll mark those as we mentioned, we'll mark those ones with zeros, right? So that we know that we have visited them. So mark the current cell as visited. So we found this first one, we'll mark it visited. We'll say grid row column is equal to 0. That's it. Now once we have marked this one as 0, we'll call the same DFS on its right, bottom, top and left. And similarly for each one we'll again do recursively for left, right, top, bottom, right? So that will cover this one, this one, this one and this one. So all these 4 ones will be changed to zeros. So we'll say explore neighboring cells in all the 4 directions, right? So we'll call DFS, we'll pass the same grid, pass row -1 column, then DFS grid row +1 column, then DFS grid row column -1, then DFS grid row column +1, right? So this way we are covering all the cells for the left, right, top, bottom. That's it. So this is the main solution. This part is just to go through all the ones and mark all its neighboring ones and switch them with 0, so that we know that we have visited them. Okay, let's run and test it. Overall time complexity of this method would be O of m into n, where m and n are, we have some issue, where m and n are rows and columns. Let's check line number 32. We missed something somewhere. Okay, let's run again. Okay, it's working fine. Let's submit. Great. Beats 99.87% of the users, so it's a very efficient approach, and plus it's much simpler, right? I hope everyone has understood it. In case you haven't, please let me know in the comment section. So that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.